So EIGRP can maintain alternate path. We know that, right? EIGRP can maintain alternate path. Where will be the alternate path? Will it be in the routing table or will it be in the topology table? Yes. In the routing table, only the best path will be there. The lowest metric path will be there. If you have more than one path with same metric, then up to 4 paths will be there in the routing table. I repeat, if you have multiple paths with same metric to reach a destination, it will show you only 4. You see in that second point, you see the default is 4. Right. Now, what if you have unequal cost path? So if you have equal cost path, even if you have 10 paths, by default it can use only 4 paths. If you will type show IP protocol now, do it. You don't need to share your screen. Type show IP protocol in any of the router. Yeah. And in that you will see max path 4. Okay, now come back to the screen. You see, by default it is 4. In the older version you can have up to 6. But in your version which you are running and the newer versions, some versions support up to 32. Some supports up to 16. How can we know that? For that, I want you to go to router EIGRP 100, enter. And then type max path and put question mark. What is the number you see? See, you can have up to 32 also. But by default, it is only 4. Now, next is unequal cost load balancing is disabled. By default, only equal cost load balancing is enabled. Why? Because the variant, this is the value called variant. What is it? It's a multiplier value. Meaning, you see, in one path, let's say the metric is 10. In the other path, the metric is 20. In the other path, the metric is 13. Now, what is the lowest metric? 10. Multiplied by this variant. Multiplied by the variant one. What is the value you will get? 10. 10, isn't it? So if you will have another path with 10, it can consider. You got it? Okay, now you see, variance is the multiplier value. By putting the multiplier value, you are telling that all those paths which is there in the topology table for the destination, whose metric is smaller than this multiplier value can be utilized. As a result, these two and this can be used. Even before you say variance, this path and this path will be there in the topology table as well as routing table. After you put the variance, this path will also be seen in routing table and topology table. You got it? Okay. So that is the variance. By default, only equal cost load balancing is enabled and maximum of 4 paths can be used. What is the rule for unequal cost path? If you increase the variance, how many maximum path a routing table can have for a destination? That is also by default what? 4. But you can increase up to 32. Now, here is the example. I want you to go through this and I'll ask you a few questions after you go through. Let me know once you finish going through this. Okay. Now, question is, without variance, which path will be preferred? Without reconfiguring variance, which is the preferred path for E to reach Z? Lowest safety, isn't it? Lowest safety. Now, do we have a feasible successor for the destination Z? Yeah. Do we have a feasible successor for the destination Z? No, no, no. AD should be less than the successor's FD. If you go via B, the AD is less than the successor value. But if you go via C, the AD is not less than successor value, isn't it? So do we have a feasible successor to reach Z? Which one? So only B will be there in the topology table, not D. So there is no point. There is no point of increasing the variance more than 2. If I put 2, what is the answer I get? Oh, you answer my question only, sir, please. If I put variance 2, what is the answer I get? 20 multiplied by 2 is 40, isn't it? So this is less than 40, this will be used. If I put the variance 3, it will be 60. Will this path be used? It won't be used. Why? Because it is not, yes, it is not even available in the topology table for consideration. You got it? That is the meaning of here saying 25 is more than 20, meaning it is not a feasible successor. It cannot be seen in the topology table. So via router D, path is never considered. You got the answer? This lab we will see another day. Okay, we need to do and see this. Okay, next. Whenever you configure EIGRP in a WAN environment, we need to consider a few things. What is WAN environment? Not only that, the serial link, okay? Not only the internet, the serial link. When you have serial link, you can have this type of frame relay cloud. Don't worry. Serial is a type of link which is point to point. And the encapsulation type is PPP, or if it is Cisco router, you may also have HDLC. In Cisco router, it is only HDLC by default. That's the encaps HDLC. That's the default layer 2 encapsulation type. It's not Ethernet. It is what? It is not Ethernet. It is HDLC. But industry standard serial link will have point-to-point protocol. Point-to-point protocol. So that is what called as WAN. Or you may also have something like this, frame relay. This is also serial wire only. Okay. Usually serial wire they will draw like this. But here they have made mistake. They just draw like this. But actually there's a kind of frame relay switch. They have a serial wire here. They got a serial wire here, serial wire here, serial wire like this. Okay, so frame relay is not that important to focus. It's an outdated technology. Now, some sort of WAN is running. It is not Ethernet. If it is Ethernet, what you will call it as? LAN. If it is Ethernet, you will call it as LAN. But do we have Ethernet here? No. We have HDLC or PPP or frame relay. Even there is much bolder than that called X.25 and so on. Now, we got a WAN link. In WAN link, you may have something like this point-to-point, or you may have something like this, a frame relay switch, where you may also have a multi-point. See, we call this in frame relay as what? Non-broadcast multi-access. Why, In the internet cloud, broadcast is not supported. That is why it is called as non-broadcast. And you see multiple points, multi-access. Is it point-to-point or multi-point? Multi-point. That's why it is called as multi-access. So in NBMA, you may have multi-point or point-to-point. If it is not an NBMA, if you simply have a serial wire, it is point-to-point. Is it point-to-point or not? Just point-to-point. If you have a serial wire, how many devices you can connect? Only 2 devices. If you have an Ethernet wire, you can connect many devices using a switch in the middle, correct? But for serial links, there is no switch. For serial link, there is no switch. So it is only point-to-point. If you want a switch, then you need to go something like this, NBMA, using some frame relay switch. It's a special switch called frame relay. That's again older technology. Oh, yeah, yes. Yes, but most of the people have migrated to gig Ethernet, 10 gig Ethernet. But earlier we had more, but nowadays we still have. I have seen in many ISPs. Even today we have it. In India, Tata Teleservice, they have a lot of serial wire. They even have frame relay in a few segment, but they are trying to replace it. Most of the things they have replaced it to MPLS kind of IP environment, but some portion are frame relay even today. Okay, now why do we learn these things? Because whenever you have a WAN link, EIGRP will take 50% of the bandwidth which is there on the link. So if you will have, let's say, 1500, if you have 1500 kilobits per second, it is going to take 750 for EIGRP and reserve it. it won't allow other traffic to use. It will go and block half of it. So if you have 50 kbps, it is going to take 25K for EIGRP. All right. So we have to do something. If it is going to take 50%, then what will happen to your so it is going to take 25%, 25 kilobits. How can we solve it? See, you may have in the wire may, let me take you to another page. You see, this wire may be 1500 kilobits per second, let's say. Okay. Now, in that 1500, it is going to take 750 kb. See, wire may have this capacity. What if you are allowed bandwidth? You have subscribed only for 256. You have subscribed only 256 kbps. Now, who is going to take the entire 256? EIGRP. So what I'm trying to say here is, we had to go and tell the wire that I really have only 256. The wire may support 1500 bandwidth, but what I have subscribed to the ISP is only 256. In that only you should take half. You can say that. Okay, you can say that. That is what WAN consideration. You see, bandwidth utilization over point-to-point subinterface using frame relay. It treats the bandwidth as T1. What is T1? 1500 kb, which is equal to 1.5 meg only. Just 1.5 meg only total bandwidth on serial wire by default. But what if I don't have this 1500? What if the committed information rate is less than that? So you need to manually say how much. Your wire may support this much, but you might have subscribed only for 256 kb. So you need to manually configure the permanent virtual circuit, which is 256 kb. You need to say my bandwidth of PVC. PVC is nothing but the tunnel, the VPN, the subscribed tunnel. In frame relay, we used to call this PVC, permanent virtual circuit. That circuit can only accommodate 256 because I paid only for that much money. So I have to say I got only 256. So that EIGRP will take half from this 256. Otherwise, problem. Otherwise, it will take 7050. In that, your committed information rate already gulped by EIGRP. EIGRP has chopped it. EIGRP has eaten it. So you will not be able to communicate. Okay, so see this point here. If it is point to all EIGRP, no. Only one vendor supports EIGRP, which is Cisco. EIGRP is not supported by many vendors. EIGRP is Cisco protocol. So these things will never come in other vendor. The story is same. NXOS is Cisco. NXOS supports EIGRP. So same story. Right. Now let us assume you got one hub router and you got spokes. How many spokes? 10 spokes. Each spoke's bandwidth is 56 kbps. Each spoke's bandwidth is, this is one spoke, this is one spoke, this is one spoke. This is hub. That's the English term. If you take a cycle, there is one hub in the middle. This is the rim. This is the hub. And this is spokes. This is spokes. This is spokes. You see, it's same like this. Yeah? Cycle rim. This is the hub, the middle one. We call this typology as hub and spoke. That's how they named it. Now, if you have 10 spokes and each spoke's committed information rate is only 56, meaning you are allowed to use only bandwidth of 56 kb. So what you can tell is, you can tell I got only 25 bandwidth. So that EIGRP will take half of it, like 12.5. Right? You can say like that. And on this router, on the spokes, this 25 multiplied by 10, because you need to talk to 10 guys. So 250 or 256, you can say. See, here is an example. You have a serial interface subdivided into two. So one physical interface subdivided into two, in which one is multi-point, means this is multi-point. And the other one is point-to-point. Physically one interface, you have logically divided into two interface called sub-interface. You can do that. So now if this guy has got 56, then you can say I got 56. But here, in this sub-interface of multi-point, if this one guy has got 256, how many multi-points you have? 3 multi-points. So you have to say 768 in here. You need to add all the 3. You understood? In multi-point, you need to say the sum of bandwidth of all spokes on this hub side. You need to add all the bandwidth of the spokes and write on the hub side. In point-to-point, you don't need like that. You just say whatever is committed information. Did you understand? This is very rarely you will see. I told you, no. The serial 0/2 is a point-to-point. I draw it like this one line. This sub-interface, serial 0 is divided into two logical interfaces. One logical interface is point-to-point, another logical interface is multi-point. So multi-point is serial 01, which is only connected to this, this, and this. 3. Did I answer your question? You're in mute. Sir, you're in mute. Did I answer your question? Yeah, 2. 0.1 is defined as multi-point. So you need to see how many points it goes, and then you need to add that bandwidth. For point-to-point, whatever is the bandwidth, you can say straight away. Right, so that is WAN consideration. That's the end of this chapter. In this chapter, we learned global summarization, which is also called as auto summarization. We learned interface level summarization, which is also called as which is called as manual summarization. We also learned load balancing. By default, it supports equal cost load balancing. You can increase the variance to make it support unequal cost load balancing. At last, we saw WAN consideration. By default, the EIGRP will take 50% of the bandwidth from the WAN interface. But if the committed information rate is lower, then you have to specify the bandwidth manually. Yeah, I need to simulate frame relay. But see, for real world, this is not needed. But you want to see, then I can show you. In the real world, definitely will never come across this. All right. So we'll see that a bit later. Remind me. Next is, you see, every routing protocol supports authentication. Some supports clear text authentication. Some supports MD5 authentication. Now, some new version even support SSL. Now, EIGRP here, we are going to see supports both MD5 and plain text. Sorry, only MD5. OSPF, if you see, it supports both. It supports simple password, which is plain text. It is also supporting MD5. Whereas EIGRP supports only MD5. But some version, as I said, it supports even not SSH, SHA. We call it as SHA. MD5 or SHA. Yeah.